The day, right? And the assignment was to come up with a list of all the interfaces that you encountered in one day. Now, I'm eager to see that list, but who gets the award for the most number? How many did you have on your list, you know?
I think maybe a dozen.
A dozen?
Maybe, yeah.
A dozen, okay.
Maybe.
Maybe a dozen, okay. What about you, Natalie? 15. Okay.
There are probably a lot more that I didn't list.
Yeah, okay. You okay. What about you?
Less than that.
Less than? What did you come up with?
8.
8, okay. Well, you guys fall way short of what
I
the...
have at times lots and all of them.
See, okay. Yeah, I think there's one guy in my class had 130
Wow.
Wow.
in one day, encountered. Of course, he counted everything like the shower and, the doors and all that kind of stuff.
I included them.
What's that?
Did he include like each door handle?
Well, no, I think a door handle. I don't think that each door handle, but the handle getting on the bus and things like that, things that he touched or interacted with. Now, here's the trick question. What is the most unusual interface that you had now?
3D mouse.
A 3D mouse. Yeah. Oh, okay. 3D mouse. Okay. That's. What about you, Natalie?
It's not really unusual, but the thing kind of different on my list is a computer game that I play called Guild Wars 2.
Oh, yeah?
Based on that.
Uh-huh. So you're a gamer? Yeah.
Yep.
Okay. What about you, Michael?
Tabletop wargaming.
Okay. Yeah, I had one student that actually the most unusual interface was a 8-track audio player. You guys don't even know about that, do you?
I know what an 8-track is.
8-track tapes. Did you know about that?
They play 8 songs at the same time.
No, I mean it's just it records on on 1/4-inch tape, magnetic tape, but there are 8 tracks on it. Usually there's 4 tracks, so you can play it in one direction, get 2 tracks, and you flip over the thing, or it reverses automatically, plays the other 2 tracks. But this way it can go back and forth, double that amount. Now, audio quality isn't that great, but that's olden day kind of stuff. That came after the vinyl. Okay.
You can record it off your radio too.
Yeah. So that's right. I did a lot of that. Okay, now each of you selected one of these interfaces to critique. What about you, Michael? What did you critique?
The tabletop wargaming.
Okay. And what was good about it?
Could change your alarm clock. That's a
Alarm clock? Yeah.
Sorry.
Yes, I could just turn the alarm. Pull it out of the wall, the alarm clock. But the table, I'd like it to be computerized. So measuring's easier.
Mm-hmm.
And people are fairer.
Ah.
You often get people adding in extra base space in their movement and cheating.
That's cheating.
No, I do it.
Yeah. Okay. So what about you, Natalie?
I brought this example up in another class. When I'm bored, sometimes I play a free Spider Solitaire game on my iPad.
Mm-hmm.
And it doesn't even have the rules.
Uh-huh.
So for someone who's never played Spider Solitaire before, it's nice and simple, it looks pretty, but when you go into the main menu, I would assume that there's something that allows you to look at the rules.
Mm-hmm.
There's nothing there. And also they've simplified some of the buttons to the point where you don't know what they mean. So having some way of actually telling the user, this actually means that you can drag it or you can click there and it will move the card for you, kind of thing.
Mm-hmm. So there's not a tutorial first time you play it?
Nope.
Okay.
This
is an iPad app. Yeah. Okay.
I was talking to Lee and this brick of a phone came out.
Mm-hmm.
Take this one. Amazingly
chunky and bad. And yeah, it's just confusing. Really, the screens are always orientated landscape, so you've got to hold it like that if you want to use it. And just doing anything's confusing.
So not only is there a problem with the electronic interface, but the physical ergonomic side of things is.
Well, I think actually the ergonomics is all right. It's just that the rest of it, it's mainly the interface that's designed really badly. Like it's always meant to be like that, but you want to hold it like that. Right. But then, like if you take out the keyboard, you do want it to be like that, right. But it just doesn't go between the two. So I think it's really the GUI that makes it all bad. So it's confusing, and there's no back buttons on the screen or anything like that.
Okay, Timo, have I been leaving you out? Are you also doing this exercise? Oh, okay. Well, you can catch up if you want to. Now you know what the questions are. You're operating that today. That's sort of interesting and unusual.
And apparently it's not as easy as I thought.
Okay.
Because last week, earlier this week, I explained to James how to operate it.
Half explained.
Which was, for me, it was always just clicking one button. It was basically what it did. But apparently there are some other things happening, which I didn't know they were happening. So for me, it was completely obvious, but explaining it was impossible because I didn't even know it was a certain way to do that. So he recorded a blank screen. The audio was there, but the rest was just a blank screen.
Oh dear.
I follow the directions perfectly.
You can follow my direction perfectly, yeah. So there's an issue.
Yeah.
It doesn't actually show what it's doing.
But isn't it interesting now how people are paying attention to the interface, and they didn't used to? I mean, when we were just accepted what we were given, the telephone. I mean, the way the telephone was designed and the push button thing. All of this was thrust upon us, and people didn't necessarily talk about that much, about the interface. But now, even my wife complains, about things. You'll see something, she says, that's a really poor design, interface design. So it really is, people are more sensitive to that now. They expect things to be intuitive. They expect them to be ergonomically designed. And in the next 10, 20 years, let me tell you, this is where the action's going to be. Is going to be not only in remember the 4 things I mentioned that we have to design for? Well, yeah, that too, but gosh, I'm really making an impact, guys. There was.
It's a clue.
Oh, well, there were 4 things I had. Efficiency, effectiveness, intuitiveness, and what was the 4th one? That has to do with emotional connection.
Emotions.
Likability. Okay. So, if you guys will send those to me, email them or turn them in to me, appreciate that. Okay. Thank you. All right, now, just a little review of last time. Remember I went through some definitions. And the 5 definitions I was interested in at least being able to say from my standpoint had to do with technology. And that when we talk about interfaces, is not necessarily interfaces to an electronic device. It can be an interface to lots of other tools that we use, like hammers and saws and screwdrivers and things like that. But the tool is there to help us perform a task that we perhaps won't be able to do otherwise. And so what we're concerned about is how we build an interface of that tool that makes it those 4 things: efficient, intuitive, effective, all that kind of thing. And that our process of working with it is what we call interaction. So we want to try to meet these goals. So really what we're working on is what goes on between these faces with the goal of getting bandwidth to and from the brain. Also, last time I talked a little bit about how an interface can make a difference. Remember the fighter aircraft situation I mentioned in terms of aiming the whole airplane, and that becomes a real challenge. Whereas with a very simple interface and instrumenting the pilot's head position, we can aim weapons off bore sight and other systems, and therefore make it a much more intuitive, easy to use, and it makes the machine-human coupling a much higher bandwidth. And then I went into sort of why we needed to be thinking about human interfaces, because there are a lot out there that are really poor, and the more complexity we're putting the hands in to every citizen, the more we have to think about this design. So that's why you guys are here. You're taking this MHIT so that you can you can solve this problem. All those people puking around the world as a result of poor interfaces. And again, the 4 factors of what makes an interface most useful. It's easy to learn, gets your job done, and it gets it done in a timely way and with a minimum expenditure of resources. And what I'm talking about there is your energy, your physical as well as cognitive energy. And then finally, you like it. Likability is becoming, the big thing now. I also introduced this model. Looks like a really complex model, a so-called box kite model, where we have all these interacting factors, and that the interface is really, you can't say there's just one interface. It's all of these things, including the meta level, where you as a designer have to be communicating with the user, the user models. So this becomes really important. I'm going to talk about this a little bit later. Now my plan, I'm trying to take 47 years of experience and compress it into the 4 lectures. I'm not going to get everything in, of course. Today, the first lecture was talking about really setting the groundwork, is the definitions and things like that. Today I'm going to talk about the human side of interfaces. Next week, the machine side of interfaces, and then putting them all together into applications for the 4th lecture. So the agenda today is to really talk about how humans work and to look at these processes that take place on the human side. I want to talk a little bit about what's been going on in human interface science. And right now it's pretty much been an art and not a science. Now we're trying to migrate toward the science side and so forth. So here we have sort of another representation of what I'd showed you before, in that we have this direct interaction where signals are actually being physically transferred between the human and the machine. The displays across to the senses, and then the motor control back to the controls. And this is a transduction layer. But then we have all these other layers that are more indirect, like the perception to signal processing connection, the cognition to the program that's there, or the content. The human builds models. On this side, the designer builds tools to try to help those models get built. And then both of them are involved in the process of task manipulation, because it's this that you're really trying to accomplish. And this is only a means to the end of doing this. But this is what you have to design with the end in mind, that the human over here is trying to accomplish this task. Okay? Now let me simplify that diagram by sort of showing you this one. This sort of talks about the human task in a tool with all the interactions that take place. This is the primary information path here. But then there are influence paths here. Obviously, the tool is going to influence the task, and the human is going to be influencing the task, but through the tool. Not always, but this is, for the sake of argument, let's use that. Okay, let's look at this human person now. So we're concentrating now on this side of the diagram. And let's start with sensory input. So here's the first layer, which is the transduction layer, and the top part of the transduction layer, which are our sensory end organs. Okay, now, we have how many senses? Very good. Normally we think about how many? 5. Yeah. We normally think about 5 senses, okay? What are these senses? Okay, so we have sight, we have taste, we have audition, smell, touch or tactile, but I said 6. What do you think the 6th is? It's proprioception. Okay, now I want everybody to do an experiment. What is proprioception? What is proprioception? You guys know what proprioception is?
Like you see ghosts.
No, it's not.
Yourself or like an individual?
Proprioception is the body's awareness of itself in terms of basically the movements of the limbs. Okay, everybody close your eyes. All you guys close your eyes. Now take the index finger of your right hand and place it on the tip of your nose with your eyes closed. Now open your eyes. Wow, pretty amazing. How did that happen? You didn't see it. It was proprioception. Think about it. You had a robot. You had to program a robot to do that. How many degrees of freedom we're talking about here? I mean,
6.
degrees of freedom? Probably more than that when you count the fingers and the wrists and the elbows and the shoulders and things like that. Huge number of degrees of freedom, and yet, with our eyes closed, we could do this. This is the body's sensing of itself. It's truly amazing. So,
a fun experiment where they got someone to touch their nose and then altered the electrical signals to make it feel like their arm was extending, and so they just felt their nose was meters long.
Yeah. Lots of experiments have been done in that using the motor cortex. Okay, so proprioception is another sense that we have to take into account, but there really are more than that. As Michael mentioned, it depends on how you count. We have sight, sound, taste, smell, touch, and I mentioned proprioceptions, but which sort of is the kinetic body sensing of itself. But we have a bunch of other things. We have the sense of balance, of equilibrium, equilibrioception, of pain, of temperature, of hair motion. Think about that. I don't have much of those sensors left, but a hair motion, the wind blowing in your hair, you can really sense that. You can even sense the direction and how much it's blowing. Yeah. Can you do that, Eduardo?
I tried to.
And then there are all these internal sensors that connect to our internal organs that we absolutely need to have. CO2 sensing is important too. You guys know what happens in operating rooms when there is general surgery taking place and you're putting the patient to sleep. You know how you do that? You put a patient to sleep? You actually kill them to begin with. You inject them with a drug that stops them from breathing. So you're not breathing, right? And then you have about a minute to intubate the patient, which means that you put a tube down into the trachea, plug it into the machine, and the machine starts breathing for you. So now, how do you get the person to breathe again once this is all over? So the surgery is over. You pull out the tube. What do you do? But remember, their lungs are paralyzed. Yeah. Sorry?
Stimulating drug for the heart start pumping.
No, the heart's pumping all along. You don't want to stop the heart. As a matter of fact, we don't even stop the heart now for open heart surgery. You know that? We don't do open heart surgery.
And how do you stick a new heart in?
We do it with robots. So what happens is, here this surgeon is in a Da Vinci machine, his head in this machine, his hands into these actuators, and then the patient's in another room with these robotic arms going in with small incisions that are made to put these probes inside underneath the skin, and then the heart is beating, right? But the surgeon sees the heart still. So in this display, the heart is still, but the robot is moving up and down, taking into account of movement. So the surgeon can actually operate on the heart while it's pumping. Problem with open heart surgery is you have to stop the heart. You got to do the perfusion. You have to take the place of the heart beating. Uses all kinds of blood, lots of infection. Bad, bad, bad. But here, it's minimally invasive. You're out in a couple of days from major heart surgery. Amazing to see it done. Now, but how do you get breathing started again?
With carbon dioxide.
Exactly. That's right. What you do is you just pump carbon dioxide into this patient instead of the air that was breathing, and you know what happens? The lungs kick in, because there's this sensor in the body that senses the CO2, and when that CO2 starts, there's this main signal that goes bang into the lungs to make it respond.
So it doesn't, probably goes a lot faster if you inject CO2, but if you wait, in theory, it should start to fall.
You have to wait for the drug to wear off.
Okay, there's also.
Yeah, and you don't know necessarily when that's going to be. You got to
But
metabolize that drug.
The CO2 injection cancels that impulse is
It overrides it. Yeah. It's amazing. I used to design anesthesia machines, so in the cockpits for anesthesia machines, so that's why I know about this stuff. Yeah. Okay, now, there's more to it than that, because it's not just like all of these senses act separately. There's an aggregation of them. In terms we use like, what is your sense of presence? Especially, this is a big deal when we're talking about in virtual worlds. What is your sense of presence of being in a space? And so we aggregate things like wind and temperature that help us to sense that we are present in a particular environment. From a sound standpoint, there's both mechanical vibrations that we feel and what we hear. From a motion standpoint, we have all these things that work together. From a chemical standpoint, lots of things are taking place with chemicals. Other signals, we talked about the electromagnetic and electrical signals. Our bodies are electric machines, and they're sending electrochemicals all over the place. Furthermore, our bodies are full of light. There are lots of photons that are running around inside our bodies, as well as electromagnetics. There is no way that there can be, in terms of reflexive response, you can get an electrochemical signal transported from down to the legs up to the brain as fast as it happens. So what's going on is there's electromagnetic transmission of some of that. And so that goes at the speed of light rather than the propagation of electrochemicals in the body. And then there's this whole area of what I call self-knowing. Now, it's more than proprioception. Proprioception is over here under motion. The body knows about what's going inside of it and what factors the environment has on the body. There's a whole field called kinesiology. You guys know about kinesiology?
study of the movements. I don't remember which approach.
Well, certainly that has a part to do with it, body movements and connections and things like that. But it's also connected to a cognitive function. We've been primarily talking about the sensory function, but is a connection to the cognitive function. Let me give you an example of that. Okay, let's see. Did anybody bring any lunch with them? No lunch? Oh, God. Okay. Well, let me do this, all right? Okay, James, you're a pretty strong guy, right? Yeah, no. Who's the strongest guy in the room here? Well, let's start with Natalie. Okay, Natalie, come up here so we can get you on video.
Damn.
Okay, I'm going to do a little experiment to show you about kinesiology. Come up here a little bit. Okay. All right, now, what I'm going to do is test your body about some things, okay? And because your body's going to be communicating to your motor control functions, and we can probe basically what's going on in your body based upon that. Okay, now what I'm going to do is ask you to hold out your right arm, okay, like that, and I'm going to try to push it down, okay? And I'm going to push as hard as I can to push it down, okay? But you're going to resist it, okay? All right, I'm going to put my hand on your shoulder here, right? Now, push back now. That's actually pretty good. Okay, now, I want you to reset yourself. Do this. This is resetting yourself, okay? Tap 3 times. Okay. I'm going to show you a photo up here, okay? See that? Okay, put your arm out again. Tap yourself 3 times. Put your arm out again. Okay, thank you. You guys believe it?
Magic.
Okay.
Is it magic?
You guys believe it? Okay.
You know, won't you, Natalie?
All right. Let's see.
Be any picture or just specific?
I'll show you. Let's see if I can. Let me go online. I didn't organize this very well. I'll be right back for my office. Okay.
Could you
Stand by.
flick back to the previous slide?
Okay. You don't want to see that anymore, is that it? No, you go. I'm a brainwasher or something, huh?
Distract. Still thinking about the picture.
Can you notice?
If I was a robot, he wouldn't have been able to do that.
Probably could have been you.
No.
Will move
I could be a really high-tech robot that has
You
blood
have-
that's
so you're a
useless.
silent
Thank you. All right. We have some more props here. Okay. Who doesn't believe it?
Michael.
Okay, Michael, come here.
He was questioning Natalie's humanity.
I see. Okay. All right. I want to send you into the to the coffee place. Bring me a bag of coffee, okay?
I don't like coffee.
It's all right.
Tea bag and stuff.
He's got
Tea
tea.
bag? Tea bag? Okay. Oh, he's got some tea. Okay. That's all right. It's tea. All right. Okay. Put your arm out. All right. You're going to keep me from pushing it down, right?
Okay.
All right. Okay. Very good. All right. Now,
What is that?
That's what they call an orange.
But it's yellow.
Yeah, it's sort of a not ripe orange. Okay. Well, let's reset you to 0 first. Reset. Yeah. Okay. All right. Now hold that.
I'm holding an orange.
You're holding it. Okay.
Very yellow.
All right. Put your arm out. Okay. Wow. Pretty good. Okay. Put it down. Reset yourself. Yeah, you love it, don't you? Okay, put your arm out. Reset yourself.
My weakness is teeth.
So what's this?
You're smoking, Natalie.
He's not a robot. What do they know?
What's going on here?
Your other senses are taking over.
Your body knows. Your body knows what's good for you and not good for you.
Did the tapping actually do anything?
What?
Did the tapping actually do anything?
Sorry, is the
Did
what?
the tapping actually do anything?
The tapping resets the energy field around you, supposedly. Now, this is what actually the kinesiologists, the naturopathy, those. If you guys don't believe it, I'll do some more. You believe? Eduardo, you're skeptical.
It is fun watching. Yes, he's skeptical.
Come on up. Okay.
Oh, cheers, it's coming up.
Everyone's queuing up.
Okay. Okay. All right. Let's make sure we start off with a good reset. Okay. Put your arm out. Okay.
I'm British.
Okay. Now I pushed pretty hard, didn't I?
Sorry?
I tried to push pretty hard, right? Didn't
Okay,
I?
yeah.
Okay. All right. All right. Reset yourself. Okay. All right. Let's look at. Okay. Here's some tea. Yeah, and it has some sugar in it, things like that.
You put sugar in tea? Kind of cruel person.
Okay. Put your arm out. Okay. What happened?
I don't know.
Reset. Okay. Put your arm out.
Amazing.
It's because you put sugar in the tea.
Yeah.
Okay.
Next one.
I'm scared now.
You don't believe me?
No, I don't.
Okay. Let's get you started real good. Okay.
It does, but what the blue
Okay.
does?
Push hard now.
What's it called?
Okay. All right. All right. Let's see. What else do we have?
Chocolate.
Ah.
I don't have any chocolate.
Cornflower.
Water.
Exactly.
Okay. All right. Put your arm out. Whoa. Whoa. That's not good. Let's reset you again. We may not have you reset. Okay.
Okay. Water.
Dihydrogen monoxide.
Need chocolate.
Chocolate? Does anybody have chocolate?
Some chocolate.
Oh, there is some chocolate in the kitchen.
Is
I
there?
got a powder.
You love chocolate, right?
I love chocolate.
You love chocolate.
Is that
In the
what says
kitchen,
trick?
that hot chocolate. You like hot chocolate?
I love hot
I
chocolate.
love hot chocolate.
If no one else.
I have to know. What's the trick?
Christmas. So is
Or
this
what's the
the
pattern?
things that people, that the body knows is bad for you and that it likes? They're different.
So
Like, was
likes
mine
it.
an example of
I
something
like
that my
this.
body knows is bad, whereas his was something that he likes? Or am I supposed to like smoking?
No, I mean it's the body knows whether you like it or not.
It's almost.
It's like a, okay. There's a little bit. Okay, just smell it. Well, let's reset yourself first. Reset. So the. Okay. All right.
Say yes.
Smells good, doesn't it?
It does.
Okay.
I have to
Okay.
get
Put
some
your arm
of
out. All right.
that. Oh, come on.
Okay. Reset. Reset. I'm not doing a number on you. I'm not really.
Weird. Really? I must know the secret.
He's got muscle weakness.
Think about this, guys. As a matter of fact, the guy who taught me this was a friend of mine who's a dentist. And he uses this technique to determine if people are allergic to the anesthesia he uses. And dentists do this a lot because they may have an allergic reaction to some of the drugs that are used and dental surgery and things like that. And they do this to test. And the body knows. We have this connection to things that we don't understand. So anytime we're using these things that we like, it may be screwing our body over like crazy. Does that mean what?
Does that mean she likes nicotine and smoking?
No, it was a weakness. And I don't know if you've ever been a smoker, but you certainly have gotten secondhand smoke sometime in your life. And so your body knows about that. But remember if I gave her something that the body likes, she would still retain her strength. But see, what this is now something else that's going on. Somewhere stored in our body, the body knows all these kinds of things. And it affects the way there's a propagation to the muscles, the innervation of the muscles, as a result of that.
My body loves tea.
Your head loves tea. Your body may not, actually. Okay, so when we look at the way these senses are mapped to the brain, we can show this homunculus. Now, this homunculus is sort of a representation of the human, where the size of the organ shown here represents the density of nerve endings in terms of what's mapped to the brain. So what would you say are the greatest, where the greatest number of nerve endings are located? Obviously the fingers, the hands and the fingers. Feet are pretty big too, right? Look at the lips. The lips are really the most sensitive part of the body. You know? And of course, you look at this. The ears are fairly large too. So this shows, that the interfaces, these limbs that we use for interfaces, have a lot of sensors in them, have a lot of sensory nerve endings. Now, when you look at the mapping of this to the brain, you see the same thing. So this is the cortex here, and you see, okay, here's the lips, and the face, and the hands, and the feet, and so forth. Now, we just can't take into account the sensory end organs, which is the transduction level. We have to go to the next level, which is how this is all organized into what we call perception. So let's move on to this sort of the second layer. And this is sort of how these things work together, these sensory transduction things. Okay, now I'm going to go just through a simple representation of this. First is that pretty much humans are three-dimensional. We see and hear and touch in 3 dimensions. That's the way we're built, our architecture. That's the way we interact in the world and grow up. It's interesting that when we get into interfaces, most of them are not 3-dimensional. They're unidimensional or 2-dimensional. So, in a way, we're throwing away some of the natural capability we have. Another thing about humans is we actually have 4 eyes. Yeah, you didn't know that. Yeah. Why do we have 4 eyes? Well, it turns out, if you look at the structure of the retina of the eye, there are 2 kinds of receptors, right? You know what they are? Yeah. Remember from your elementary psychology, there are rods and cones. Cones are the color receptors that are predominantly in the fovea of the eye, the central part of the eye. High density packing, they give you your highly detailed color vision. They sort of spike, only about plus or minus 1 to 2 degrees. in the center of your eye, the fovea centralis. Now, falling off to the side, cones fall off, but the rods take over. Now, the rods are not sensitive to color, but they are sensitive to light. And they're much more sensitive to light than cones are. And they give us our dark vision, our night vision. But it turns out the density of the rod receptors in the parafovea is greater than the cone receptors in the fovea. They also have short time constants, these rod receptors, which means that motion, they pick up motion. And these will go all the way out to the edges of the retina, which is beyond 180 degrees. So let me show you what the power of this. Okay, so put your finger in front of you and look straight ahead and move your finger out to where you just stop seeing it. Okay?
It's outside my glasses, I can't see it anymore.
Okay. Now wiggle your finger. Can you see it now when it wiggles? So this means that, that even though we may not pick up detail in our peripheral retina, we sense motion. And that's what gives us our whole feel of the flow field that happens. So the way that these receptors are processed, they're actually processed in different places in the brain. The cone receptors are primarily processed in the visual cortex, whereas the rod receptors are processed in other places that help connect to our equilibrium, our balance, things like that. So here we have this diagram. This is our whole field of regard. We get our field of regard when we move our eyes around, okay? So we actually are able to move this optical axis of the eye around, which gives us this whole green field. Of course, we move our head around too, which would expand it a lot more. But let's say just keeping your head still. And then what you have is your instantaneous field of view. It comes from your eyes. And because of the peripheral retina, we have this really wide field of view here, beyond 180 degrees even. And this tells us the where of things, the spatial orientation, optical flow, things like that in the peripheral retina. But then we have this focal vision system. The one outside here is called the ambient visual system. The one that's mediated by the fovea of the retina is called the focal visual system. And it has to do with these cone receptors in the fovea centralis. Okay? It tells us the what of things. When we are basically, what we can do is take a book. We can take a book and walk down the street and read at the same time. That's amazing. Now, we're using the saccades of the eyes, these ballistic movements of the eyes, to read groups of words here, but it's our peripheral retina that's giving us our flow field. So it's actually the ambient visual system tells the focal visual system where to look. So you have a what and a where. We throw away most of that in our interfaces. We don't take into account this power that we have of a peripheral visual system and what we can do with that. We're primarily just using this focal visual system. Now, why do we have 4 eyes? Well, we have 2 eyes and then 2 visual systems in each eye. That's how we get 4, okay? We also have 2 brains. Now, the psychologists get antsy when I start talking about this, but you know that we have sort of this hemispherical specialization. It's sort of complex, but let's just look at it from a simplistic standpoint. So you know that we have 2 hemispheres of the brain. These hemispheres tend to do things differently. There is the so-called left brain, or the left mode, we'll call it. The left mode is where we are basically acting like a laser. We're doing things in a linear way, step by step. It's a rule-based system. We have to put things into categories, things like that. On the other hand, the right mode is sort of a floodlight mode. This is where the artists live. Okay, this is the analogical. This is looking for relationships, where we are intuitive and holistic and sort of see the world and all of the pieces coming together. Right? That's the floodlight mode versus the laser mode. There's another word, L also stands for lawyers. Lawyers live on this side. You know why they started burying lawyers 20 feet deep? Because down deep they're good guys. Yeah. Do you know what you get when you cross a snake with a sewer rat? A lawyer with ethics. Actually, my lawyer friends told me these jokes, but lawyers live on the left side, all right, the left mode, okay? The artists live on the right mode. Now, when we want to take advantage of the whole brain, we need to understand that. Because generally, our interfaces are left brain and not right brain. We don't take into account this amazing capability we have with the peripheral retina and the right brain. Now, humans also, in order to survive, build models in their heads. You know, we don't necessarily process every sensory input that comes in and make sense out of it. We actually run models. When we, as infants, we start building models. That's what we use to walk. That's skill-based behavior and things like that. But we also build amazing models everywhere we go, every day of our life. For example, let me give you an example of this room. When you walked into this room the first day, you built a model, a spatial model of this room. If I blindfolded you right now and said, okay, find your way out the front door of the building, you could do it. You could pretty much make your way there. But if I brought you into this building blindfolded, then took off the blindfold, showed you some diagrams, showed you some movies, sketches, things like that, and then blindfolded you and say, okay, make your way out of this building, it'd be much more difficult to do. You build these amazing spatial models in your head. You also build acoustic models in your head. We use acoustic models like a phased array antenna. It helps us sort out the signals from the noise. It's the whole cocktail party thing. You can hear this person over across the room talking about something while you're standing here talking to somebody else. We can do that because we have this three-dimensional hearing capability. An example of that is when we walked into this room, we built a finite impulse response model of this room that helps us sort out the signals from the noise. Okay, listen. What do you hear? The air handler. We put a recorder, let's say you couldn't come to this lecture today, and you bought in a tape recorder to record what I'm saying. Guess what you'd hear when you get back home, when you listen to it? You hear that air handler. Whereas here you don't even notice it. You don't pay any attention to it because you're using this amazing spatial model that we have to sort that out. Another thing about humans is that we're different. We have different shapes and sizes. We have different cultural backgrounds. We're different. Let me show you an example of that. Okay, I'd like for all you guys to clasp your hands. Okay? And how many of you have your left thumb on the top? How many have the left thumb on the top? Okay. A lot of left thumb people in this. Right thumb? How many put neither thumb? Actually, we usually have a 6 Sigma person that does no thumb. We'll do this. Okay, so here we have some difference there. And that's the way you do it almost every time you clasp your hand. Let's fold your arms, okay? Everybody fold your arms. Okay, now how many of you have the right arm on the top? Okay. So I assume the rest of you have your left arm on the top. Okay, keep them folded. Now reverse it. It's not right, is it? So we're all different. We have our different desktop organized in different ways and things like that. So we're all different. And we have to understand that when we build interfaces. Not everybody is going to want it the same way. people are going to want to customize their interface. Okay, let's move on a little bit to cognitive considerations. Up to this point, we've been talking about sensory, perceptual organization, things like that. Let's talk about cognitive. Okay, now cognitive is when we start getting up the brain and then exercising things around. And generally what we want to do there is that's where the signals now begin to have meaning. Now signals become information because they formed inside. That's what information means. Inform, form within. The idea of information is that something is formed within you as a result of these signals coming in. But you're bringing a lot to it. In order to make that forming, you bring as much to the signals as they bring to you. So that cognitive process adds understanding and then memory to what's coming in through the senses. Now, if we look at the diagram, here we saw the sensory side. This is the motor control side. You see, it's almost the same thing, that we have about as many motor neurons dedicated to these same organs as we had sensors over here. So there's almost a one-to-one mapping of the two. Now, there's some other things that we have to think about when we think about the cognitive side. It's not just processing signals. We have these mental states. Like, for example, attention. Are we paying attention to what's going on? Have we taken our multiplexer and plugged into this? I mean, we can be doing a task and listening to the radio at the same time, not paying any attention to the radio, unless something alerts us. Generally, we have a working memory that can keep about 7 things in the air, 5 to 7 things in the air at one time. Beyond that, things sort of get mushy. And there usually isn't a graceful degradation. You just lose it. You can't keep track of more than that. Turns out that the time constants, though, of registering things are faster than we think. Because a lot of things take place in the subconscious. We actually have more than 2 brains. We have 4 or 5 brains. One of them is subconscious. A lot of processing takes place there. For example, we did an experiment when I was working at Wright-Patterson Air Force Base. We were trying to figure out how rapidly we could give information to pilots. And so we had this little display where we just put words there. We just flashed up words that's so fast that you just couldn't see them. You didn't think. And then we said, okay, then we give them a list of words and we ask them, tell us what word we displayed or what set of words we displayed are in this list. And they got it every time. So,
if you tell them write down the words that you see in the display, they will get it also.
No, but they can pick it out from the list.
Yeah. So this is.
Yeah. So, working memory, fatigue. Obviously, I mean, if you're really, if you're not getting, have your brain chemistry right, and your muscles are tired, things like that, that's going to affect it. Skill-based behavior. What is your capability? I mean, some people can do things better than other people. Some people can throw a football better than others, kick a football or sew or knit or whatever. The emotionality. Generally, people are not patient. They hate to read instructions. And that's especially true today. That's why we expect interfaces to be better. We expect to open the box and turn it on and go to work, rather than reading through a whole bunch of instructions in there. And so forth. So we have to modify our interface model when we put this up here. Obviously, there's a lot going on that is stored. And what we bring to the experience is stored up here, as well as what the sensors bring to us here. Now we have this other part of the so-called psychomotor considerations. And this is now where we've now moved through our transduction layer, through perception, cognition, bounced back up here to our memory, and now we're back going to this layer, which is transduction again, but this is the motor control side of things. And this is where we're now going to affect something in our environment by some electromechanical activity. It's either speech or moving our hands, our legs, whatever. It can also be electrochemical, because we also send out these electromagnetic waves I mentioned. Now, when you start talking about psychomotor mechanisms, you get into these domains. I won't go into this in other detail, other than that there are different kinds of ways. This is almost the perceptual layer that processes these signals, where you're trying to come up with imitation or manipulation, or eventually naturalization is where you are getting a skill-based behavior. It becomes automatic. From the actual physical mechanisms involved, basically you're starting up here in the brain, and you have now formulated a task you want to perform, you have developed a strategy for it, and then that is sorted out based upon these models that you've already developed, signals that are going to innervate or excite through electro action potentials the muscles. Now it's interesting that you see all of these feedback loops. Torque, angle, this is back to proprioception. This tells us we can tell how heavy something is, and the mass, the inertia, these kinds of things. We move it side to side, up and down. It's amazing, and how much we can intuitively know of what's going on, and that's because of all these feedback signals. So it's really complex, and it is learned behavior. Some of it internally is not, like breathing and heart beating and things like that, but pretty much the movement of our limbs to the outside world is. So if we want to summarize how humans work, we have to say, yeah, we got many senses, we're really three-dimensional, we have these two brains, 4 eyes, this kind of thing. We have all these multiple modalities, which means that we see and hear and touch and taste and all this, and that all come in the confluence helps us build these models. We also are amazingly plastic. The human nervous system is plastic. We can adapt to various, we learn something doing it one way, we can usually learn to do it another way. We have all this amazing diversity, like we're not all the same. Generally, we dislike pain, but having worked with graduate students over the last 47 years, I'm not sure I agree with that. I think students like pain, and the more we can give them, the better they feel, But also some people can be easily distracted, like me. Now let's talk about bandwidth to the brain. Now, our object, remember those 4 things. What are the 4 things?
Intuitiveness, efficiency, effectiveness, likability.
Very good. They couldn't come up with it the first time. I just want you to know that they could struggle with that. Okay, so all of this sort of maps into the bandwidth. So what we're interested in, just what is the bandwidth across here? All right, now let's bear with me a few minutes as I sort of come up with this other little model. Okay. Let's say that this represents a human. It's red, represents the skin, the corpuscles, the blood, all this kind of thing, right? This is sort of the body. This is the body, okay? So this is the sensory and psychomotor processes we've talked about. All right, now we're going to add the gray matter into it, okay? This is what we'll call our mind space. So we have our body, sensory, perceptual things, and then our brain and those processes, okay? That's from the human side. Okay, now let's look at sort of the tool side. The tool side has 2 components. There's one component that we call the message, and the other component we call the medium. And so let's use this. This now is the message. The green blob is the message we're trying to communicate, the content, the program in the machine. This now, here's the message. And this is the delivery mechanism, or the machine. This is the portal through which this content is conveyed. Okay, so the idea is, how do we get the message into the human, right? So the idea is to move that over so that's there, right? You want the green blob to get into the gray blob, right? Generally. Okay. So, what is the bandwidth of that transfer from the green to the gray? Well, there are pieces that have to do with what goes on over here, elements over here, as well as the design of this over here. Now, somewhat these are invariant, but these are ones you design. Okay? So, let's look at it. It's certainly going to be a function, bandwidth is going to be a function of what we can take in physically, what we can transduce. You know, for example, there are parts of the parts of the electromagnetic spectrum we cannot see. Infrared, UV, so forth. So there are limitations. Same with sound. Low frequencies, high frequencies, we can't hear. Same with touch. All of these things have to do with aspects of the nature of our sensory end organs to transduce these signals. Then, of course, there's the issue of the gray matter. It also is going to affect the intake of the green blob because it's going to be a function of what models have we already built. I mean, if we know something about calculus, then we're in a much better position of understanding differential equations, that content, when it's presented to us, than if we only had arithmetic, right? So we have conditioned the gray matter to receive the green blob by education, by skill-based skills that we've developed and things like that. Okay, that's the human side. Let's look at the machine side. Well, is it going to be a function of the green, the content? Well, yeah, the organization of the content. Let's say that you're watching an episode of, let's come up with something on television. How about, what's the name of the guys, the funny guys that Flight of the Conchord. Okay, so Flight of the Conchord. So you're watching a Flight of the Conchord. Now you know these guys. You've watched several of the programs before. You know their personalities, and you expect certain behaviors from them. You have now this content. If it deviates from that, it's not a very good design because it's not in context. But you want to continue to build that character. And so you take into account the model people have already built in their head when you're doing that. And then, of course, there's the tool itself, the delivery mechanism. If it isn't big enough, bright enough, enough contrast, if you don't have interactive abilities with it, then I don't care how good your content is, it isn't going to get delivered. Same is true, I don't care how good an interface you've built in terms of the hardware, if the content ain't any good, it's a lost cause. So the content and the context, the message and the medium have to work together. So actually, bandwidth is a function of all of these things. You've got to understand all of them if you're going to build an interface. All right, now, from what you've learned so far, what's wrong with this interface? Assuming the user's okay, all right.
Screen, text-based interface.
All right.
It only uses one sense.
I think this is a digital equipment corporation, VT100 terminal hooked to a VAX computer. Oh yeah, well we don't have that now, do we? We don't have these, and what's missing here? Yeah. But what do we understand about humans that says this is the wrong way to go? By the way,
It's not intuitive.
this was in 1983 I took this photograph.
Is that you?
No, that's not me. But I took that in 1983. How much has changed in terms of our interfaces? We have this.
But it's also more of a viewing text-based interface.
Not with text. Here everything is text.
We do have graphics now,
Yes.
color, screen's flatter, maybe higher resolution, maybe a little bit bigger. But fundamentally, it's the same. It violates all the rules that we understand about how humans work, pretty much. So it's doesn't match the port to the brain of the way the humans perceive and process information. It's not 3D. It uses this highly coded input in the case of the text. Not very intuitive. You're on the outside looking in. What do I mean by that?
Everything's happening behind the screen.
What did I tell you last time about field of view and displays? You remember?
Doesn't change.
I told you about the experiment we did with the Darth Vader helmet. What happened when we expanded the field of view?
Did you?
About 60. Did I tell you about that?
I don't think so.
Well, I didn't tell you about that. Oh, no wonder you. Okay. Remember the Darth Vader helmet? No, I haven't even shown you that yet. Oh, I'll have to save that for next time. Darth Vader. Think Darth Vader helmet. Problem is, we're on the outside looking in. What if we were on the inside looking out? It would be transformative. We break the glass and go inside this world that's there. That's what really virtual reality is about. We'll talk about that next time, okay? The breaking the glass is the machine side of things. So it's very difficult for us to interact with this, interact with the real world at the same time. Virtual reality, augmented reality lets us do that kind of thing. So the bottom line is this is all low bandwidth to the brain because of the way we build our interfaces. So here we have the human, and here we have the world with content that we've generated that we may want to communicate. And we have this huge bottleneck of getting the inform, the forming within from what's going on in the outside world, to get that into the brain of this person. Sorry?
Those books.
Those are actually documents. This is the way we think, well, we can access information better if we organize it. That's how much paper was delivered with a B-1 bomber.
It's like
The
that
packing.
packaging.
Huh?
The packing.
The packing. No, these are all the reports and everything.
Instruction manual.
Yeah, instruction manuals.
You say that this bottleneck is changing according to the experience of the people or the age of the people? Or...
Yeah, you're saying, okay, this is not constant. You're basically saying this is changing. That's true. And our ability to operate these kind of machines. Obviously, we build models in that let us do that. So we do have, in the domains that are germane, obviously we are building skill levels and models that let us absorb this content and make meaning out of it better. So this is a moving target as well. And of course, what we really want to do is expand this interface. We want to open it up. So now we're able to not limit. We want to do an impedance match, great engineering term, impedance match of what's going on with one black box with the other black box. When you match impedances, you get the maximum transfer of power. Any of you guys electrical engineers?
Mechatronics.
Mechatronics, that's close enough. You know. Good engineering term, impedance, right?
The impedance of capacitor and the inductor, and yay.
Yeah. All right, so we understand now about how the human works and how this may impact the way we take information. Well, just how do we go about designing interface? We have to get into the guts of all this, don't we? We have to be able to understand all these pathways. The answer to that is yes, we have to. Because we have to do that in order to get all these pieces built in order to accomplish a task. So, what about this design of user interfaces? It's really an art right now, not very much of a science. And pretty much the art comes from doing it, learning while going. And some things have been written down. But in terms of actually understanding and having robust models, we have very little of those. But we are developing some interesting tools which are going to help us build better models, these new metrics of how we measure things. I'll be talking about those in a few minutes. There are also models of what it is. In other words, in the case of the human, what's the mechanisms that cause this interface with the world? But how it does it, besides the components, the processes, that's still a little bit in the dark ages, really completely understanding that. We can track the signals, we can do all that kind of thing, but understanding what's going on in those synapses and how the dendrites get formed and things like that, we're really still in the very early days of understanding that.
Made that thing that can almost pull a picture out of what you're thinking.
No.
And if Google made the computer that can recognize a cat.
Computers have been recognizing cats for a long time.
But this one knows what a cat is from any angle and things. They showed it YouTube and it worked out what a cat is.
Now, computer vision, but not like humans.
They formed a model of a cat.
I think Google has a long way to go before they get to the mimicking the brain with its capability. But the other thing is, who owns this field? Who really owns interface design? Is it the psychologist? Is it the engineers? Computer scientists? Who owns it? It's really a hybrid. It's like nanotechnology. Who owns nanotechnology? Everybody. I mean, it spans, it cuts across. So that's part of the difficulty. You have to, in order to do it, you've got to cut across. And the different understandings, the different disciplines that pull these pieces together. I'm going to propose a design process that is for designing interfaces that pretty much is a one-to-one map with systems engineering principles. So let me back up and ask you, what is the first thing you do when you're designing a human interface? What is the first question that you ask?
What we need. What is the necessity?
Getting close.
What's the
What is it supposed to do? If I ask you, I said, okay, hand out pieces of paper. I said, design me a computer. First thing you do is you start sketching, right? And you probably sketch something like you're familiar with, something you've already done. And but you don't ask the important question, well, what are you going to do with this computer? I mean, what is it supposed to do? And that is the first and most important. In what I call problem characterization is identifying the problem. What is it supposed to do? For whom is it supposed to do it? In what environment does it have to work? How well is it supposed to do it? And how much should it cost? And because you can almost design something to do anything, but is it affordable? Is it producible, reproducible? Things like that. And then the next thing you do is say, okay, how will I know I've succeeded? That's really important, that feedback. Because unless you are able to measure it, you don't know if you've done it. Now that measurement may be subjective, questionnaire of the people that use it, or it may be objective by some other means. How will you measure it? And then you have to drive a stake in the ground. You have to start somewhere. And usually you have to start with a whole bunch of assumptions. You're going to make assumptions about this user, about their background, their experience level, their age, whatever, about the tasks they're trying to perform, and about the environment they're going to do it. You have to make these assumptions. maybe those assumptions are educated by talking to the users. Hopefully they are. And then you look at your constraints. You know, what is my schedule for doing this? What kind of resources do I have? What can it cost? This cost is a big thing. And because you need to be thinking about that up front, not toward the end. And you need to consider all of the capabilities of your people that you're working with, because you're usually not working by yourself. Now you get into the actual design part of it, identifying the solution. That has to do with a lot of, hopefully a lot of creative thinking. If we have time at the end, I want to give you some new tools for creative problem solving that you probably haven't used before. So you come up with these possible solutions, and then what do? You build it, test it, and you repeat. So this becomes an iterative process, and you tune it as you cycle through it. Now, depending on schedule, you may not be able to cycle many times. I have my students cycle 3 times in their user interface design. They have a whole quarter to design an interface in teams. I select who's in the team and the project that they work on, and then they have to have at it doing this. And then you document it. You document it the whole time, because you're going to come back and look at those documents often. You say, why did we make that decision? Oh, that was a wrong assumption. So forth. So there's this cycle, the so-called design cycle. But here's the most important thing. The Furness 10 Commandments for interface design. You ready for it? Commandment number 1, thou shalt know thy user. 2, thou shalt concentrate first on what it's supposed to do, not what it is. You guys have to remember these. I'm going to ask you next time, all right? Thou shalt remember that the interface is only the means to an end and not the end itself. Just like I talked about last time about Jaguars. I mean, the Jaguar is the only thing I know that's an end in itself, because you just sit there and look at it in your garage because it won't run. Okay. Thou shalt observe, observe, observe. What's worked in the past. Thou shalt consider what has worked before. Thou shalt keep it simple. Keeping things simple is complex, actually.
Where's the second
You can make it up, what you think. We have various graphic terms to describe that. Thou shalt design for redundancy. You know, it's especially because of this next one, I believe it is, yes. Thou shalt be sensitive to Murphy's Law. If it can break, it will. Bill Gates is a great example of that. How many demonstrations he's done where it didn't work? Mind you, most of Steve Jobs did, but not Bill Gates. Thou shalt be willing to adapt. This is adapting things that have worked before. This is adapting yourself to other people's ideas. Need to be flexible. It's a moving target. Thou shalt remember that thou art not the user. And we do a lot of our designs thinking we are, but we're designing for somebody else. Okay, so those are the 10 Commandments. But this is really tough to do. When you're looking at a population of users. So I'm going to suggest a technique. It's called a persona. You guys ever heard of this?
Yeah.
Okay. This was actually something that arose out of some of the stuff that we were doing. I'm sure other people did this too, but independently we did this with one of my students. So, the question is, who are you going to design for? Since you're not the user, you're biased, you have inside knowledge, you're using this designer's perspective and so forth, you don't actually know what people want. and what they'll do with this. So, who is the user? Is this user from a large population of users? I mean, a broad spectrum, more narrow, whatever. The problems with trying to design for a population is you can't be very specific, and by the way, you can't please everybody, and so forth. So let me propose another approach. Let's say that we were going to design a car, the perfect car, and we have these potential users. Now here's Bill. Bill is a carpenter. He works, he has a workshop behind his house. He makes beautiful finished carpentry. What kind of vehicle would he want?
Something can hold lots of things.
Probably a pickup truck. Yeah. Okay. Here's Jackie. Jackie is actually a business executive. She works for an investment firm in downtown Seattle, and she meets with clients often and looks at their investment portfolios and tries to encourage them to invest in a particular way. And it's really important for her to project an image of prosperity. What kind of car would be her car?
Helicopter.
A what?
A helicopter.
A helicopter. That's out of the box. That's good. But if it's a car,
SUV.
Some sort of sedan. Sports sedan.
what kind of make are we talking about?
BMW, Mercedes.
Yeah. So we're talking about sort of high-end luxury cars, a Beamer or whatever. All right, and so let's look at the other one. This is Mary. Mary's a mother of two. She's a stay-at-home mom. She is active in the kids' schools and things like that, and taking them to sports games and things like that. What is her ideal vehicle?
Some sort of hatchback, like a van, SUV.
Bus.
A what? A bus. Yeah. So let's say that we're designing for this population. What is it going to look like?
A monster truck.
It doesn't make anybody happy.
Monster truck would make everyone happy. And they,
So if we're trying to please the masses, we'll maybe please half of them. But let's say that we're trying to please these photographers, these high-end photographers. You can make them 100% happy. So that's the whole idea, is try to select one person that you can make happy. And that's what the persona is. So this is what I do in my Phase 3A and the phases that my students have to go through. And they have to create a prototypical user. They invent a person. I mean, and they go into it. They give this person a name, a gender. They make a Facebook page for this person. They do the Myers-Briggs psychology profile on them. Everything you can think of. Talk about their pets, a day in their life, their parents, their aspirations, everything. And they come up with this picture of this person. And that becomes a member of their team, this persona. And that they keep asking this person, what do you think about this design? And then they crawl in the head of that person, looking through that person's eyes after creating them, and say, ooh, she isn't going to like this. And so that is the use of a persona. And it turns out there's a great book, actually written by one of my students here, Tamara Adlin, called The Persona Life Cycle, that talks about using this method. So there is some practice in interface design, like these kind of tools, a persona tool. There are some others. And if you want to find some excellent resources, you can go to these books, and you'll have these slides so you'll know what. Some of these are great. The Inmates Running the Asylum and Orbiting the Giant Hairball. This was written by a guy that did greeting cards for Hallmark for a number of years. Very interesting book. Okay. Now the question is, okay, you have this persona. Where does this persona live? Where would the persona live in this? Who has to have a model of the persona? Yeah. So what you've done is basically transported this over here and try to put it inside of you, internalize it, so you can design for that one person. So back to the commandments. Well, the idea is your user is embodied in that persona. And you go on down here. When you're observing, you're going to be observing the persona. As a matter of fact, you're creating a day in her life using your interface and what she thinks about it. And then finally, 11th commandment is you listen to your persona. Okay. Now, how do you measure goodness of this interface? You've done it, you built it, you used your persona. Okay, now how good is it? And then you've got to somehow figure out a way to measure these things. We probably don't have time today to talk about those. So what I'll do is stop there and pick it up next week, where we're going to get in more of the tool side, machine side of human interface. Then remember, the last one is about the applications themselves. Any questions you guys have?
Yeah, I was thinking a little bit about my research, and I have the robots to do the research and so on. So is it different design an interface than an interaction? I mean, there are different things.
Well, again, in my definition, the interaction is the activity that takes place through the enabling capability of the interface. So the interaction is what kind of interactions are made possible, what affordances exist in the interface to allow you to have these interactions. I mean, can you talk to them? Can you touch them? Can you hold them up and move their limbs around? So those are all parts of the interface, but your action of doing that is the interactivity piece of it. That's the way I define it. So back to your question. I don't really understand what
my question is, for example, once that you have some kind of interface, in my case, for example, the robots, with an interface which can have speech recognition, artificial vision, something degrees of freedom, and so on. And you're thinking in how you can use all these kind of things together in order that you can create some kind of specific interaction with one user. So all these principles and all these commandments that you show us to be applied in this process, because I'm not designing the interface. The interface that I have is a set of systems without a goal. You know, they are all together in an embodiment of a robot, but we don't have.
Well, there can be the programming side, though. The programming would be that. Well, I would say that you go through the same process in terms of asking, what is it supposed to do? What do you really want this robot to do? It's a tool, and you want this tool to help you accomplish a task. What is that task? And then if you define that task, then you get eventually work down to, okay, understanding the modalities that are already in that machine. How can I exercise them to perform that particular task? What is the most intuitive way of doing it? One of the ways I would suggest, we came when we were working on gestural control. Well, this is one of my PhD students about 15 years ago was working on 10 years, working on gestural control. We said, well, what kind of gestures you use to control the computer? And we didn't know. I mean, we were the designers, of course, but we didn't know. So we basically went out and did a survey. We took, I think, 50 people and said, okay, you're operating the machine that has a graphical user interface, you know, this flow field, things like that. And we want you to move in that world. What do you do? They said, well, I would point where I want to go. Or, well, what if you want to stop? Well, I would do this. And so what we do is do that research to find out, to create a library of intuitive gestures that most people would use to control this. And that's that became the library. And so what we had to do is sense those then, with our our state vector machines in order to determine what gesture was really, when is the gesture happening, what is that gesture, when does the gesture end, and to come up with a semantic context for communicating. So I think that's what you need to do, is because there is some programming that you can manipulate in the robot itself, given those effectors that it has.
Yeah, I guess the problem with the robot is that you have the intention to imitate the human behavior using the robots because they have something
Right.
like anthropomorphism and so on. But at the end, you have a lot of constraints and limitations. So the outcomes are unexpected. You know, it's like you're expecting that the user react in some point, like in the same way than a human, for example.
Yes.
But definitely the robot is not capable all the times to.
Well, that's why you don't necessarily want to have a preconceived notion. One of the things you could do is do the homunculus experiment where you pretend to be a robot. What would you do if you had these constraints and you had this task to perform? What would you do?
It's a good idea.
And then you see what they do. And you may find that they don't necessarily do what you think is the best would be the way that a robot would do it. If they want to get to the most efficient and effective solution to a problem, a task.
Yeah.
Yeah. Other comments or inputs?
I was just wondering about personas. I've worked with personas quite a bit before. But for instance, in case of Ryan's seminar yesterday, like, he was his own persona. He was designing for himself,
Yes.
and then basically find out that this is something for the community. So yeah, just in that case, I suppose you can design for yourself.
Well, yes. I mean, if you, let's say that you are a juggler and you want to create a training tool to, like he was doing, basically, that would be different. But what if you were not a juggler and you're trying to do it for these people? Be entirely different. But yes, you're right. I mean, if you are a skill-based person, but even that can be restrictive, and that may be the worst thing you do is to be experienced. Sometimes ignorance is bliss when it comes to doing these designs. The tendency would be not to think outside the box, although I think Ryan has, but yeah. So I want you to go home and do this experiment on your friends. Remember to reset them.
We might be trying it in the last year.
Yeah. You didn't see the experiment. Let's do it on him. What's that?
I'm gonna do it.
Okay. All right. You do it. All right. All right. Let's let me find the slide I want first. Okay.
Is the Ellen line?
The right. Okay. Reset him. Okay. Hold your right arm out. No, the side. Yeah.
Okay, right.
All right. Now put this arm on his shoulder and push down.
Don't let me put your arm.
Okay. Now this is, let's take your T.
Does he have to reset again?
Reset.
The T.
You know what that is?
You like tea?
Okay, he's a T guy. Okay. Put the arm out.
You didn't reset him.
It was a little hard. But it was possible, yeah.
Was it different?
It was a difference.
Okay, reset him.
Okay. Arm out.
Okay. Let's wait.
Oh, sorry.
No, don't stop. Reset. Do this. Like that. Right here in the middle, yeah. Okay. All right. Hold that. You know what that is, yeah. Okay. All right.
Do it again?
Mm-hmm.
Nope. Different.
He's a robot.
Okay. What's going on?
Guess he really likes tea. I'm not sure.
It's not at sea?
If you really like tea.
It's experimental.
Tea is your weakness. Your kryptonite.
Boyer tea is
Well, I also really like citrus. So.
I don't think you can smell it, so maybe that.
It doesn't matter. Body knows. I can show you a bunch of pictures. I can show you pictures of these things, and it'll work. Works the same way. It's amazing. Any other inputs?
It's what your body.
Did you experience this yet? Okay.
Right. What your body doesn't want, isn't it? Not what you like.
Right. Okay. All right. Reset. Reset.
I'll see you after lunch.
No. Do it this way. Yeah. Right hand. Right hand. Okay. Now hold your arm out straight. Okay. Push back as she pushes. Okay. Very good. All right. Now let me show you a photo. I want to. Let's see. Where is it?
You're not still videotaping,
Yeah.
right?
Okay. Here we go. I want you to look at the.
I will come up.
Okay, you can look at it here.
Yeah.
See that?
Mm-hmm. Yeah, here we go.
Okay. See that?
Do we have to
Okay.
reset again?
Yeah. No, he's reset.
Oh, you are.
Yeah.
Don't do it.
Okay, look at that. All right, now.
That was better.
Okay, reset again. Okay, put your arm out.
I'm sorry.
I
need more practice.
Kryptonite is having your arm broken.
Okay, reset again. Okay, all right. Put it down, okay. Okay, better look at apples again. It may not be that good for you. I'm serious. If you can try it again. Let's try one more time. Reset yourself. Okay. Okay.
Yeah, cool.
Whoa.
Yeah. Okay, let's do the orange.
Probably take up smoking.
Let's take the. Oh, we probably ought to take this off the screen. Actually. Okay. Let's. Can we kill this?
Oh yeah, I
Okay. Here we
Does
go.
he have to
But are you
reset
doing
again?
it with the
Reset.
same
Reset.
force? Are you doing the same force? Yeah.
Well, less
Yeah.
force when it went down.
Okay. Mmm.
So why
Either
are
that,
you
you're just a really weak fin, or.
So what's the purpose? Like some objects make you weaker? Or
The body knows about what's good for it, and generally, that if there's something that doesn't work well in the body, it recognizes that, and there is a weakening of your in terms of the energy balance in your body, and that's what you're doing is resetting. When you're doing this, you're resetting that energy balance.
oh
Yeah, the so-called chi, and yeah. So it didn't work as well on you, but let's take a tangerine. Let's take a sandwich. There's a ham sandwich. Okay, resetting. Okay. Now what you're supposed to do is you're supposed to resist as strong as you can.
I guess smell it.
Okay. Interesting.
Would you like some?
Tom, I think you need to give you a sandwich to Thomas now.
That's right. Yeah. I'll eat these and you eat those. Yeah. Okay, guys.
Thank you.